Hello friends! In the third and final video of the series, we discuss on creating the geometric form for the drawing of an industrial object. We will try to understand what the surface analyze method is and how it works during the surface creation process. With this method, we will get an idea of how to correct surfaces that are in contact with each other but have poor surface permeability and how to create surface geometries with the fluid permeability. If you're ready, let's get started. If you've seen the previous one, part 2, we discussed how to make surfaces coming from different angles, but we're going to go through it briefly and make the surfaces transitive. First of all, I would like to remind once again what needs to be considered. First of all, we need to create two different reference lines from the surfaces. For this, we use the extract wireframe command. Then we accept these created two lines as reference and connect them to each other with the blend curve command so that the transitivity is curvature. In the next steps, we will use this to weave a surface. Now that we have created the surfaces we will use, it is important to create usable sections for the surface knitting commands. We will use split commands for this, but there is a trick point here, and that is where to split. For this, let's follow these steps in order. We will use this point to this point in large circles, this point to this point, then this point and this point. After splitting the first circle of the large cross section with a split edge, we do the same for the second large circular cross section. Then for the small circular section, we first split it completely in half horizontally. Because we will connect these lines with a blend edge and trim them after we have created a surface. After trimming, we will divide this line in half in the middle and proceed to sweep operations. After completing the surface knitting operations, whether we explode all surfaces and select the zebra test from the Analyze menu, or open the zebra test before exploding, it seems that the surfaces have problems with continuity, that is, transitivity. The zebra test projects a horizontal or vertical strip on the surface for us. By tracking these projected stripes, we get information about the surface geometry. We can also see sharp and hard continuities and discontinuities when we approach our scene in shaded mode before running the zebra test. Now let's do the surface operations in order and see the result. The first rule of surface operations: apply the refit command to the surface. What this does was explained to you in video 2. Then apply the rebuild command to all surfaces and use the values you see on the screen. And finally, we will intersect the horizontally and vertically touching surfaces by marking the surfaces where different surfaces that touch each other intersect each other with the mate surface command and selecting the join type we marked as curvature. Then, if we join all the surfaces and turn on the Show Naked Edges option under the Edges tool from the Analyze menu, you will see that there will be no unconnected or open area on the surface. Turn on the zebra test and you will see a perfectly fluid geometric shape. After completing the surface transitivity step, we took the symmetry of the upper surface and turned it into a hole with the join command. Then we filled all the planar gaps with the cap command. After that, we will add the details on the reference image and detail our first industrial object and make it ready for rendering. In this section, we will make the details we will add using revolve and simple primitive objects. Then, we will separate our object into two parts with the wire cut command and show it like a mold trace. In order to fully model the details on the front and back sides of the object according to our reference image, it is more accurate to use the curve drawing method by making reference lines instead of using basic primitives after the surface transition stage. There should be at least 2 or 3 of the contour points of the curves on these vertical reference lines. Otherwise, your curves will not have a smooth geometric transitivity, and we call these points as tangent points. When we turn this curve into 3D with the revolve command, we can fillet this edge by about 4M with the fillet edge command, since the the part of the object that intersects with the main body has a very hard transition. But in order to do this, you must first revolve the object and then close it with the cap command, because the object you create with the revolve command is a surface and not a solid. For the front side of the object, the detail on the front side of the object is completed with a cylinder and a 2-point sphere object drawing. We may prefer to make the back part with revolve again, but I will do it that way to show you how to do it with the use of a primitive object. After this stage, we will create the mold line of the model with wire cut. After making Boolean differences on the front and back parts of the model, we will soften the remaining hard edges of the object from which we removed parts to show that the parts are intertwined. From this moment on, I share the rest of the video with you as it is. I will not do any editing and acceleration. Have a good time and have fun. See you in our next video series.